welcome to one of the online training tutorials. Today we're going to be looking at EMF, so electromotive force. Here I have two bottles, both with the same amount of water in. Okay, and we have a tube connecting the two bottles. Okay, now at the moment, as you can see, the two bottles are equally filled and there's not much movement of water. The water's pretty still. Okay, so not much is happening at the moment. We were going to call this at the moment equal potential. Okay, so we'll call this equal potential as it is now. If I was to remove some of the water from one of these bottles or add some of the water to one of these bottles, we're no longer going to have that equal in potential, and therefore the pressure in one is going to be more than the other, and we're going to end up having the water flowing from one bottle to the other bottle. So we're going to do that now. Okay, so I've started filling up the bottles. I've filled up this one here, so I've filled this one up to nearly the top. As you can see, the water line here, and on this bottle over here we have the water line, you can see it around about here. Okay, just try from the other side. So here is the water line on this bottle, and we're going to wait and see what happens. We're going to give this 5 minutes or so, and we're going to wait to see what happens with those water levels. So we're now 5 minutes later, and we have the two bottles. Okay, we have this water line just above the label here, and we have this water line just above the label here. Now what happened there was we had an unequal or a difference in the potential between the two bottles, where we had one bottle had more pressure than the other bottle, so it released some of its pressure into the other bottle. That's what we'll call a difference in potential. Okay, now for me to get movement from one bottle to the other, I've had to put in some sort of effort. I've had to put some water in myself to get that movement, or I've had to change the pressure in the two bottles to get that movement. And that was some sort of force or energy that I've had to put into those two bottles. Once the water has reached the equal level again, the water then stops moving and equalizes again. Okay, so if you like, we'll call this voltage, and voltage is a difference in potential. In electricity, it's whereby I have a difference in pressure, if you like, between one point and another point, and we can measure that anywhere in a circuit. Okay, and to get a measure of voltage, we've got to have two different potentials. Potential A is bottle A, potential B is bottle B. With the two bottles, we can see the two different points of potential. Okay, now in an electrical circuit, if I was to take a lamp, okay, so I've got a little makeshift circuit that I've made myself here. I wonder what that's been made out of. We've got a little LED light, we've got a little switch, and then we've got some cables. Okay, so we've got a little 9-volt battery. Okay, I'm going to connect on the 9-volt battery, which is my force. This is the force, isn't it? At the moment, there's an equal in the pressure. So no matter what happens with this switch, or with anything that happens in all these conductors, in all this copper and everything that's going on here, we will have an equal pressure everywhere in that circuit. So if I was to take a measuring device such as a voltmeter, and I was to measure between the positive and the negative conductors here, I would find that I would have 0 volts, 0 volts. Okay, now if I was to take my battery source here, and I was just to take the battery source and put it on the positive terminal, and put the positive terminal on my red cable and nothing else, as shown here. Okay, as you can see, I've got no light. No matter what I do with the switch, there's no light. However, I still have 9 volts running through all of the circuitry. However, it's not connected to the other side. So what's happening is the 9 volts of pressure, if you like, there's no difference. There's no potential difference. It's 9 volts all the way round. If you like, there's 0 volts altogether, because my 9 volt battery is causing no change in pressure. I have to have both sides of this battery connected. Both the negative terminal and the positive terminal need to be connected to enable me to have a difference in that potential. So if I was to take this battery and place the positive terminal and the negative terminal, as you can see there, the LED lights light up, and if I let go of the battery, the LED lights turn off, and I put the battery back on, the LED lights turn on. I take the battery back off, the LED lights turn off. Okay, so quite obviously that's going to happen. The voltage that's generated by the EMF, this is the EMF, the battery source, and the voltage is generated by this battery source. Just like if I was to add pressure to one of these bottles by blowing into one of the bottles and forcing air into one of the bottles, or adding some more water. In the case that I was to force water to move from one to another with, let's say, my oxygen, I could blow into that and get that movement of water. As you can see, there's no movement of water, there's no water leaking out really. And we saw them bubbles going across the pipework. That would be me being the EMF, and the pressure that I've created would be the voltage. Okay, so that's where we talk about voltage and EMF, slightly different things. EMF is the source that keeps that pressure there. Voltage is that pressure, if you like. In our electrical circuits, the voltage moves electrons through this LED, and the electrons release the energy. Okay, moving electrons release energy, and in an LED light, that's how that will work. It will release some energy as it passes through that component. It releases some energy as light. So we give it some energy in the form of moving electrons, and the moving electrons give out that energy in the form of light. Now, with current is a measure of charged particles that move in an amount of time. So charge is measured in coulombs, and 1 amp is equal to 1 coulomb over 1 second. Okay, and what that basically means is that 1 amp, if I was to measure 1 amp, that means that we've got 1 coulomb of charge that I've measured over a time of 1 second. Okay, so what does that really mean? Well, if I took a conductor and measured it over that period, I'm going to be looking at approximately 6 times 10 to the power of 18 electrons travelling through my conductor. Okay, so that's 6 with 18 zeros after it. Electrons, that many electrons, more than billions. We're looking at 6 million tera electrons. Okay, so loads, ridiculous. 6 million terabytes of information. We're looking at 6 million tera electrons travelling through our conductors. Hence why we don't say electrons, because that's what it is. We call it current and we call it amps, and that's a measure of the charge, of the amount of electrons that are moving through that conductor, and we call that 1 coulomb. 1 coulomb is equal to 6 million tera electrons, and we're looking at that over 1 second time, and that will give us 1 amp. Okay, so time comes into it, charge comes into it, electrical charge, the charged particles that are actually moving through these conductors. Okay, and if we think about it, electric charge divided by the amount of time that we've measured that electrical charge over will tell us how many amps we have, how much current we have. Okay, generally we'll measure the current. Okay, we'll measure the current with an ammeter to measure how much current we've got. Okay, and that measure of current will be due to the amount of electrons that are passing past that section of cable that we're measuring, and it's got to pass through that meter to be able to measure current. Okay, so later on in the series you'll see that current is measured in series with the rest of the circuit, and voltage will be measured in parallel to the rest of the circuit, so over the top of the circuit. Okay, so between the positive and the negative, or between two sides of a component. Okay, and you'll see that with resistance and resistivity, and we're going to go into that later on in the series. Okay, so pretty much today that's about all we've got time for. We've spoken about the water and the pressure in the water and the difference, and we've spoken about the EMF, the voltage and the current. Okay, we've spoken about them negatively charged particles called electrons that make up what we call charge, because those are negatively charged, they're going to make up a charge, and those negatively charged particles moving through our conductors is what we refer to as the current. And the current, as that moves around the circuit, it will be pushed by the voltage, and the voltage will be generated by our electromotive force, or our EMF. Okay, thanks for listening. Any questions, by all means leave us some comments, and